Hello, I would like to go over the answers for the study guide. Okay, so the first question says, the weight of each cookie in a batch of a certain type of commercial produced cookie follows an approximately normal distribution with a mean of 11.32 grams and a standard deviation of 0.03 grams. Approximately what percent of the cookies weigh between 11.32 and 11.35? So you can use GeoGebra for these. So if you downloaded the app, you can just go and input the numbers. So the mean will be 11.32 and the standard deviation will be 0.03 grams. And then we say that you want it between 11.32 and 11.35. So 11.32 and 11.35, that will be 34%. So and you can see it here, 34%. So that's it. If you were to answer this, it will be just 34%. And that's it. Really, there's really nothing else to do here. All right, question 2. When Lynn drives a golf ball, it travels a mean distance of 200 yards with a standard deviation of 20 yards. And the distribution of length is approximately normal. Approximately what percentage of her shots will travel less than 180 yards? So I have 200 yards here as the mean. Oh, clicked the wrong one. So 200 is the mean, and I think the standard deviation was 20. And I want to know how much is less than 180. So I'm going to move the cursor here. It doesn't matter where you stop here, like you can stop there, you can stop there, it doesn't really matter. What matters is that I need to bring this so that is less than 180, and that will be approximately, so this is the shaded region and this is the percentage, so that's 0.1595, so that will be definitely 0.16. So let me just copy this down here and then change it to 16%. And that would be my answer. Okay. Question 3. It says, Jada creates a survey to find out how current freshmen from a university feel about the difficulty of their first semester courses. She plans to give the survey to 100 people. How should Jada select who to give the survey to so she can find out how current freshmen at the university feel about the difficulty of the first semester courses? So first of all, you want to include here freshmen that come from all over, right? So you don't want to just include people who come from, let's say, low-income families, middle class, or rich people. You don't want to include only people who maybe are immigrants coming from like other countries, like international students, for example. You want to make sure that you are open to all of them, okay? People coming from other countries, people coming from low-income families, like you want to include everyone. So the only way you're gonna do that is if you ask randomly, right? So this is the idea of having a random selection and through a survey, okay? So if we were to put here an answer, okay, we can say something like Jada should give a survey to current freshmen at the university, and she should select the 100 students at random from the list. Okay, so something like that, so that you are not biased in just selecting a certain type of student, right? But you are including everyone. So that's that for number 3. Let's move on to number 4. It says a veterinarian finds that weights of the population of each dog breed tend to be approximately normal distributed. They know that the mean weight of beagles is 25 pounds with a standard deviation of 3 pounds. The mean weight of a Great Dane is 150 pounds with a standard deviation of 20 pounds. The veterinarian finds that about 68% of the beagles weigh between 22 and 28 pounds. What can this tell you about the Great Danes? So the way you're going to answer this question is, first of all, knowing that they tell you here that this is normally distributed. So the minute they say that, you know that you have to use the empirical rule. So I'm going to use my GeoGebra here app, and I'm going to input the information. So it says here that the mean is 25 and the standard deviation is 3. So 25 and 3. So this program automatically would always give you the first 68% of the data. Okay, that would always happen. So you go back here and then you check if it's true that they tell you what they tell you, right? So it tells you here that the veterinarian finds about 68% of the beagles weigh between 22 and 28 pounds. And you can confirm that in here that that's true, right? Like they tell you here 22 and 28. So the way you're going to tackle this problem, is by comparing what they give you of the beagles to the Great Danes. If they're telling you that 68% of the beagles are between 22 and 28, then tell me, okay, what can you tell me about the Great Danes? Tell me the same thing. Tell me what's the percentage, okay, or not. Well, the percentage should be 68% because that's what the problem is talking about. But what will be the range of that 68%, okay? So they're telling you a fact from the beagles. Now you have to translate the same thing to the Great Danes, okay? So now they tell you that the Great Danes have a mean of 150 and a standard deviation of 20. You come here and then you put 20. And so what you found is that the first 68%, or the first one standard deviation within the mean, is going to be between 130 and 170. So you can answer something like about 68% of Great Danes between 130 and 170 pounds are within one standard deviation of the mean. Okay, and that's it. There's really nothing else to do there. All right, next one. It says, Mai gathers a random sample of 30 students at her school and asks them whether they would be willing to start and end the school day 1 hour later than usual. 27 of the students agreed that this would be a good idea. Now, letter A. Mai goes to the principal and says, exactly 90% of the students think it's a good idea to start and end the school at an hour later than usual. What's wrong with this statement? Okay, first of all, if they're telling you that they have a specific percentage, that means that think about what you're given in these problems that you are not given here. How do you know what is 90%? Like, what are the two things that you need in order for you to know that exactly 90% of students think it's a good idea? And if you're telling me that the two things that you need are the standard deviation and the mean, you're correct. So ask yourself, is this given to you? I mean, read again the problem. I gathers a random sample of 30 students, okay. And then, okay, 27 of them agree that this would be a good idea. That's it. If anything, you can just find the percent of like, that's almost 100%, right? Like 3 people disagree. It's almost 100%. Let's check if that's what you want to do. So let's check 27 divided by 30. So 27 divided by 30 is indeed 90%, but this is the problem. The problem is that there are 2 ideas that you are stating here. The idea to start the day earlier and end the school day 1 hour later. So it seems like here you have like 2 different ideas that you either want to start or end, or both, like what you want, right? So we need to make sure that we have a distinction in what you're asking, because I can tell you I'm willing to start and end. I'm willing to start early and end early, or I can agree to start early and then end late, right? Like it seems that there is a bit of a confusion here as to what do they want, okay? What exactly they want. So for these, we're missing information here. Actually, we cannot just say yes, that's true, okay? Because we're missing information. So we can just say here, the data is not enough. Okay, the data is not enough to provide an exact proportion of students who agree to make the school day an hour later than usual. So this was a bit tricky, I guess, and I think it's very easy to say, well, it says they're 90%, that's exactly 90%, but it goes beyond that. Okay. All right, next one, it says, after collecting more data, my reports that the proportion of students who think it's a good idea to change school hours is 90% with a margin of error of 3%. Okay, so what does this mean? So I think here the word that like throws us off is exactly 90%, because that might not be true. Okay, so let's come here. Again, it says, after collecting more data, my reports that the proportion of students who think it's a good idea to change the school hours is 90% with a margin of error of 3%. Okay, so now makes more sense, because now you're giving something that you can work with. You're giving 2 things. You're giving the proportion, and remember, the proportion in this case will translate to the mean, okay? And the margin of error in this case will translate to the standard deviation, okay? So if you come here and then you say, now my proportion then is 90% of the students, so that's the average, and then I have a margin of error 3%, this will translate to actually the standard deviation. So that's how the spread this is. So that means that the actual proportion of the students, okay, is most likely to be between 87 and 93%. Okay, if you were to write something, and we checked that here that that's actually true. Okay, so this means that the actual proportion is most likely between 87% and 93%. Okay. All right, I'm gonna stop right here, and I'm gonna do this next problem in a separate video.